Hello, 8th grade. Today we're going to be looking over lesson 43, which is simplifying rational expressions. This is one of the bigger lessons we have for a little while, so there's a lot to get down. Buckle yourselves in. It's going to be a ride. So the first thing we need to review is what exactly a rational expression is. And a rational expression, remember when we think rational, we look at the beginning of the word and we see the word ratio here. And what a ratio is a fraction. So the first thing we should be thinking of is fraction. So what a rational expression is a fraction that has variables in the denominator. A fraction that has variables in the denominator. What we're working on today is making sure we can simplify them. So a few lessons ago we talked about how to simplify expressions finding their greatest common factor, and we're going to go over that as well. But the first thing we need to make sure we recognize is one of the biggest rules in math, which is we cannot divide by zero. So we cannot divide by zero. And that's going to be one of the biggest rules. So the first thing we have to do when we're looking at a rational expression is to make sure that we are not dividing by zero. So we're going to look at a few examples here and just make sure that we can find what places, what we have to do to make sure we're not dividing by zero. So just as a quick example, if we have x plus 8 divided by 4x, we can tell this is a rational expression because it is a fraction, and on the bottom there is a variable here. And because there is a variable there, we are going to have a rational expression, and that also means there's an opportunity for the bottom to be 0. If the bottom's 0, that means we're dividing by 0, and that's a bad thing. So we're just going to look at the denominator here, because that's what we're dividing by, and our denominator is 4x. And we're going to say, well, that can't equal 0, so we're going to try to figure out when it does equal 0. So 4x equals 0 is what we're looking for. And to find what x is, we're going to divide by 4 on both sides, and we end up with x equals 0. So when x equals 0, our denominator equals 0, and that's a bad thing. So we can say now that x cannot equal 0. And the way we're going to write that is x does not equal 0. So we found that the denominator equals 0 when x equals 0, which means that x cannot equal 0, which we write right here like x does not equal 0. So if we are simplifying this expression, the first thing we're going to do is we're going to write it as x plus 8 over 4x, which is what we started with, and then we're going to write x does not equal 0. And that's just to make sure that we understand that we cannot have x equal 0 for this to make sense. Another quick example we're going to look at is going to be 2x plus 1 divided by x minus 4. And again, our big rule is that we cannot divide by 0. So looking at the bottom here, we have x minus 4, and we're thinking to ourselves, we have to make sure this is not 0. So to find that, we're going to look at times when it is 0. So we're going to say x minus 4 equals 0. And to solve for x here, we're going to add 4 to both sides. So we're adding 4 to both sides, and we end up with x equals 4. So that means when x equals 4, we are dividing by 0, which tells us that means that x cannot equal 4. So our simplification is going to be 2x plus 1 divided by x minus 4. X does not equal 4. So again, what we did is we looked at the denominator here. We told ourselves that can't be 0 or else we're doing something we can't do. So we found when it does equal 0, and then we said that cannot happen, which is this x does not equal 4, but at the bottom. And we're going to look at one more, a little more complicated example, and that is going to be x plus 5 divided by 3x plus 21. So we have x plus 5 divided by 3x plus 21. And again, the first thing we're going to do is we're just going to look at the denominator and tell ourselves we cannot divide by 0. So we're going to set our denominator equal to 0. 3x plus 21 is our denominator. We're setting that equal to 0. What we're going to do now is solve for x again. First step here is going to be to subtract 21. We get that 3x equals negative 21. Divide both sides by 3. Divide by 3. And we get that x equals negative 7. So x equals negative 7, of course, means that x cannot equal negative 7, because if x equals negative 7, we're dividing by 0. And that would be bad. So, by saying x does not equal negative 7, that is good. It's a good thing to have x not equal to negative 7. So when we're simplifying this, we're going to write x plus 5 divided by 3x plus 21 with x does not equal negative 7. So that's kind of the easy part of this. We're going to move on into the harder part of simplifying, and that's by using a common factor. So what we're going to do now is we are actually going to find the greatest common factor of both the numerator and the denominator. And just as a example problem, we're going to start with 54x plus 9 over 4 plus x. And what we want to do first is we want to find the greatest common factor of the top, and we have 54x plus 9. And the greatest common factor of that, we're going to do a factor tree, 54x and 9. 54x breaks up into 54 times x. 54 is 9 times 5. 9 is 3 and 3. And 9 over here is 3 and 3. So our greatest common factor is going to be our two 3's. When multiplied together is 9. So if we're factoring the top of this, we can say that 54x plus 9 is the same as 9 times 5x plus 1. If we do the same thing to the bottom, we'll eventually find that there is no greatest common factor. So we're just going to leave it how it is and divide that by 4 plus x. And that's going to be the first step to simplification. After that, we're going to do the exact same thing we did beforehand, setting the bottom to 0. So we have 4 plus x equals 0. And we have that x equals negative 4, which of course means that x cannot equal negative 4. So we have 9 times 5x plus 1 divided by 4 plus x by pulling out our greatest common factor. And we have that x does not equal negative 4. Moving on to a different problem, we're going to have a bit more happen when we take out the greatest common factor. Is we want to look at 2x squared minus 10x over 4x squared plus 6x. So the first thing we need to do is to look at the greatest common factor of our numerator. So our numerator has 2x squared and 10x. So finding the greatest common factor here, our 2x squared will break up into 2 and x squared. X squared turns into x times x. And our 10x will turn into 10 and x. And 10 is the same as 2 times 5. So if I'm looking for my greatest common factor, I find a 2 and an x on both sides, which is really nice. So I end up having that this is the same as 2x times x minus 5. Would be the same thing as 2x squared minus 10x. Then I'm going to do the same thing on the bottom. On the bottom we have 4x squared plus 6x. And by doing a factor tree here, I'm going to do this separately with the 4x squared and the 6x. My 4x squared is going to be 4x squared. 4 is 2 and 2. X squared is x and x. And my 6x is going to be 6 and x. 6 breaks down into 2 times 3. So finding the greatest common factor, I have a 2 and an x for both of these. So we're going to write 2x times, that would be 2x plus 3 on the inside. Now I know what everyone is thinking, and that is that we have something that's the same on the top and the bottom, so we should just go ahead and cross that out. But that's not actually what we're going to do first. The first thing we have to do from this point is to make sure our bottom does not equal 0. Make sure the denominator does not equal 0. So this is a very good start, but we have to make sure that 2x times 2x plus 3 does not equal 0. So we're thinking about when this would equal 0, and this is going to equal 0 either, because we have two different parts, and two different parts will equal 0 when either part equals 0. So if I multiply 5 times 0, that's going to give me 0, or 0 times 5, that would also give me 0. So if 2x equals 0, I'm in trouble, so 2x cannot equal 0. And if 2x plus 3 equals 0, I'm also in trouble. So 2x plus 3 cannot equal 0. So I'm going to try to find x for both of these. If I have x equals 0, or 2x equals 0, I divide by 2. I end up getting x equals 0 there. And for 2x plus 3 equals 0, I subtract 3 from both sides, get 2x equals negative 3, divide by 2, I have that x equals negative 3/2. So now I'm going to take this top part, copy it again down below. I have 2x times, let's see, that was x minus 5, divided by 2x times 2x plus 3. And we have that x does not equal 0, and x does not equal negative 3/2. And now that I have that taken care of, I can now cancel these out. And after I cancel that out, my final answer is going to be x minus 5 divided by 2x plus 3, where x does not equal 0, and x does not equal negative 3/2. Very cool. I know these are fairly long problems, but I have full faith in your ability to do these. So I'm going to give you guys a sample problem right here, which is going to be to simplify 3x squared minus 3x divided by 9x squared plus 15x. Because I know a lot of people missed the class where we discussed finding greatest common factor of expressions. I believe that was lesson 38. 38 was simplifying expressions using the greatest common factor. So if you didn't quite get how we simplified these into, for example, right up here where we got the 2x times x minus 5, that was using the using greatest common factor, which is in lesson 38. So you can either look at that on your own or come in and ask me for help. I will see you guys in class.